Good afternoon, everyone, and welcome. This is Aaron Smith, the CEO of the Energy and Environmental Building Alliance, and we're pleased you are joining us today for the eBuild webinar podcast series. We've got a group of our experts and friends from Carrier that are going to be talking about some of their new heat pump product, which I think is extremely exciting. Um, Last summer, I was in Europe and went in a lot of mechanical room closets and looked at some of this new heat pump technology over there. And I know many of you are extremely excited for it to come to the United States. So with that, I think I'm turning it over to Nick Armstrong here to kick off our presentation, but we will have the Q&A section open. You can put questions there. You can vote the questions up and down. We'll have some of the other team with John and Jason perhaps answering those, and we'll save some of the questions for the end of today's presentation. So welcome to everyone, and most of all, Nick, thanks so much for joining us from the great state of New Hampshire.
Thank you. Thank you for having us. Let me get the slide deck up for everyone. And just confirm that you do see that?
Yeah, you're looking good.
Awesome. Great. So again, thanks for having us. Everybody who's on this call here, I see that we've got people piling in, so that's great that there's interest in this. So in this session here, I just wanted to explore how Carrier is expanding its residential comfort offering with an air-to-water heat pump system, a competitive solution for the domestic hot water as well as HVAC solutions. So you've got myself. I'll give a brief introduction to the product line here. Then we've got two of our technical sales managers on this call as well. Jason and John, who will each go through some of the slide deck with you as well. So we'll start off with a quick product introduction. I just want to give you a clear understanding of how the system works, some of the unique benefits, and we'll dive into hydronics a little bit. There may be people here on the call that are familiar with hydronic systems as part of their offering, and maybe others who are not. So we'll give a quick little introduction on that, and get into some of the energy efficiency and design flexibility that comes along with that. We'll take a quick look at the installation and some best practices on how these systems can simplify setup and integrate seamlessly into a new modern home, and how that targets both energy savings as well as cost savings for the homeowner. And as you can see from the image here that's in the slide, it's a multi-part product line. So it's got the heat pump, which is the outdoor unit. It's got an indoor unit as well as a buffer tank as the basic units. And then there's also a domestic hot water tank that all seamlessly integrates together as part of this solution. Well, hoping by the end of this, you guys have a good understanding of what it is that we're offering and bring into the market here to kind of help lead that next generation of sustainable home offerings. And before we get into the technology, I'm going to dive into a little bit on why it matters. So, at least in the U.S., when we're talking about the U.S., heating, cooling, and domestic hot water account for about 3/5 of the home's energy consumption, with the HVAC unit eating up the majority of that, and then hot water obviously coming up the rear there. And really, those are the loads that we're targeting with this air-to-water heat pump system. So we want to combine space conditioning with domestic hot water into a kind of an efficient platform that's meaningful and easy to use. We believe this is especially important as we move towards more electrification at the home level. And even in the U.S., we've got some regulations that are in place coming from the DOE on rules around hot water, and I'll get into a little bit of that as we move forward. So again, looking at this as an opportunity to achieve those goals of reducing energy consumption and providing a sustainable solution. This slide here might be a little busy, but this one illustrates how the system operates into a home's ecosystem to maximize the efficiency. So at the core here, you've got the heat pump itself. And, unlike traditional resistive heat systems, the heat pump uses a variable speed refrigerant cycle to deliver that high efficiency and consistency that we're talking about here. The challenges with a standalone hot water heat pump is they can overcool a space. And what we're trying to do with this system here is not put that load back onto the HVAC system itself, and again, not compromise comfort. And as you look at the diagram on the left side of the slide here, you'll notice that there's controls and sensors in that diagram. And that all brings the smartness of this technology together, so that you've got precise temperature management, and again, moving towards a more seamless integration with other hydronic devices in the home or emitters. So in short, what this slide is really trying to demonstrate here is it doesn't just heat and cool. It's intelligently capturing energy and redistributing that in the home effectively. So let's just take a quick moment. I want to highlight some of the benefits on this system. So you can see here that they've got a high efficiency rating on them. And ultimately, what this does is this provides, as you go downstream, the homeowner lower utility bills than going with potential other technologies. The product itself is AIM Act ready. It's using an R32 refrigerant, which has a lower GWP. So this positions itself for long-term regulatory compliance and environmental responsibility. Again, that's a core for us here. And then the last piece is that, or the third piece is that low cost of ownership with minimal maintenance requirements, durable components. Homeowners can really enjoy the comfort of what the system can provide. And then finally is the flexibility of being able to incorporate this into multiple different areas in the home, whether it be emitters like radiators or radiant floors, even putting that into some chilled panels or ice melt products to the driveway, whatever. So it really is adaptable to a wide range of both new construction and even some retrofit possibilities. So that's that in a nutshell for the product at a glance there. This slide here is going to highlight really the fundamental difference between an air-based system and the hydronic system that we're talking about here. Often using the direct expansion or DX cooling for modern home hydronic systems. The air-based system, these typically rely on just refrigerant to move heat directly into the coils. And then with the hydronic system here, you see that we're using the water as the heat transfer device, or the heat transfer medium, if you would. And the benefit to that is water is much more thermally conductive than air. So we're utilizing that thermal conductivity to absorb that heat and move that efficiently. And then the hydronic system, integrates or allows you to integrate with domestic hot water. So you've got different zones called out throughout this layout here as well. Excuse me. So in short, what I was trying to get at there, it just offers a more efficient, versatile, integrated approach to home comfort and domestic hot water. So to talk a little bit on the hydronic side, specifically the product that we're talking about here, this air to water heat pump system. The first bullet on this slide here talks to the efficiency of that heat transfer, and that goes back to the previous slide where I'm talking about the thermal conductivity of water being 23 times higher than air. The second piece here is it's quiet, so it's unlike a forced hot air system. Operates silently. It's got flexible designs. Whether it be the radiant floors or fan coils, zoning strategies, all of that's available as part of the solution. And then third is really the integration into the home. And that's what Carrier wants to do here, is be able to provide a total home solution for both builders, dealers, and the homeowners ultimately, by having an integrated system that isn't just about heating and cooling, but takes care of that hot water piece as well. And that's what the hydronic systems offer, a more efficient way to heat and cool, and Carrier systems are designed to make that transition very, very simple and easy to do with this technology. We'll get into a couple of the market drivers. I touched on it a little bit earlier in the slide deck on the Department of Energy's rulings that are coming out or have come out, but targeting in the year 2029. I believe it's May of 2029. They've got the hot water heater rule, which will require most electric storage heaters, 35 gallons or higher, to use heat pump technology as an alternative to resistive electric heat. Clean energy tax credits and utility incentives and statewide incentives have really moved the technology and the adoption forward. And the DOE rule remains in place, and many of those key rebates are still available going forward. They haven't been sunsetted at this point. Residential hot water industry, I believe, is on the cusp of some major transformation as we're moving towards electrification, whether it be this DOE rule and those incentives that I spoke about, but more also driving towards that sustainability approach that many people are moving towards. And this applies to the residential hot water heaters. They once they no longer have the option for the electric storage, they're going to be looking at either tankless electric or gas-fired, whichever alternatives, and this gives an additional alternative to those solutions. So with that, I want to pass it over to John so we can get more into the technical weeds here. And John, if you take over, I will jump off camera.
Very good. Thank you very much, Nick. So we're going to take a look at some of the breakout of what makes up the kit for this product, and so we'll move forward. First will be the outdoor unit, but just before we get to that, we have the bits and pieces of the kit. We have an outdoor unit. It's the larger two components to the left. A smaller of the two there is an indoor unit, which communicates to the outdoor unit. It does this through it's called a Modbus communication, and all the information from the outdoor unit is communicated into the indoor unit for sort of that cockpit type of interaction. Do a smaller tank down to the bottom right there is a buffer tank, allows the outdoor unit to have proper running times, so it doesn't short cycle. At the same time, too, it provides a buffer of fluid, whether it be heating or cooling, so that if you're in a domestic hot water mode, it allows not an interruption of either that heating or cooling. And just behind that is the domestic hot water tank. And as Nick was saying, this is a sort of a one-stop shop type solution for hydronic heating. It does your heating, it does your cooling, and does domestic hot water as well. Okay, slide. So the outdoor unit, what makes up the outdoor unit, of course, is a dynamically balanced fan blade. It's got a nice Nice baked enamel finish, jacketing. It's a pre-charged R32 refrigerant, so that's important to keep in mind. It's not something you have to charge up at the time of installation. It's already done for you. Monoblock design. It has a robust inverter-driven variable speed rotary compressor, and of course, it also has the large evaporator coils. It's corrosion resistant as well. Okay, slide. Bit more in depth as far as what the components look like. The rotary compressor there to the left, the braze plate heat exchanger built into the outdoor unit. It is insulated to have a maximum heat transfer between the outdoor unit back into the indoor unit and into the home. And down on the bottom right-hand side of that slide, you have the reversing valve. The reversing valve acts as the ability to allow the outdoor unit to either provide heating or the cooling option for the home. Some of the specifications for the outdoor unit. Now, as we said before, it is a pre-charged unit. You don't necessarily require a license requirement to install the unit, but of course, to work on it, if you're going to bring out the gauges to do measurements on the unit, you're going to require that license. Some of the pre-charge we have on there 726 on the 28 up to 972 on the 78. There are three sizes of this unit. It's a 28, 43, and 78, and I refer to that as 28,000 BTUs, 43,000 BTUs, and 78,000 BTUs. Okay, next slide. So here's where the customer is going to interact with their kit, and we refer to this as the indoor unit. It's as I said, it's the cockpit. There's a lot happening inside this very small box. It's about 18 by 28. It's not a very large box, and inside there we have a pre-charged expansion tank, pre-charged to 14 psig. So it comes right there for you out of the box. All your electrical connections are right on board there. Your IOs are also on board. You have a built-in air vent. Now, with hydronic systems, air is probably the one largest obstacle to providing consistent heat. And having an air vent built into the indoor unit is a really handy thing to have. Now, we certainly wouldn't say you only need one air vent. There's nothing wrong with having more than one air vent in a system, and we always asked that you would put an air vent at the highest point of the system to allow the removal of air from the system. Circulation pump built into the unit as a safety PRV, which is set for 30 psig. There's a three-way valve also built into there with a manual override. The three-way valve acts as the ability to divert the flow through the heating or cooling or into a domestic hot water production. You have electric heating backup inside this unit. For the small sizes, there's two coils. For the large size, there's three coils. And it provides either up to about 20 to 30,000 BTUs of backup heat, either for domestic hot water or for heating. And this is programmable as well. So you can tell the indoor unit, you can say that at a certain outdoor temperature, I'm not going to be providing enough energy output to either adequately heat or warm up the domestic hot water. So I want to bring my backup coils to supplement that heat. And all that is being done on the control panel. And it's a white interface control panel. It's a sort of you scroll through type menu structure. Okay, next slide. So some of the specifications, it requires a 240-volt single phase connection to the unit. It does have a little bit higher amperage requirements, 40 amp for the two small sizes and 50 amp for the large size. And that is specifically the higher amp load is because of those backup electric coils built into the indoor unit. And as I was saying before, the two small sizes have two 3 kilowatt output coils, and the large size has a 3 kilowatt. Okay, we're gonna pivot here, and I'm gonna let Jason take over and talk to you about domestic hot water.
Okay, thank you, John. Okay, next slide. Okay, here we go. Okay, so it comes with a 20-gallon buffer tank. Temperature range from 45 to 230. And this buffer tank can easily mount on top of the domestic hot water tank. Next slide. And just as I mentioned, you can see that the it saves space, smaller footprint, but you cannot mount the tank on top of the buffer tank just because of the weight. We have three sizes, 53-gallon, 66-gallon, and 70-gallon. These are ceramic coated with a powered anode system that's for corrosion protection. Next. Okay, integrated carrying handles. There are two sets of handles to make transport easy. Has a large coil for better heat transfer. This tank has been specifically designed for heat pumps to provide better domestic hot water recovery in a heat pump application. It is well insulated, thick foam insulation, and it is zero protected, enamel coated, and it has integrated clean out ports. Now, okay, go ahead. Corrosion protection. It comes with a powered anode system. The powered anode is a titanium anode. It has a better, the manufacturer says it has better corrosion protection than stainless steel tanks that do not have corrosion protection. So with this system with the anode and the tank, it should last for a very long time and outlast stainless steel tanks. And the straightforward wiring for the anode, yeah, so you can't mess that up. Go ahead. Okay, so you have one kit with everything you need. It is a monoblock design, so you don't need to worry about refrigerant charging. You really don't even have to hook up any gauges to the unit. All the pressures, temperatures can all be read through the outdoor or through the indoor unit. It's easily serviced. You can remove the top of the outdoor unit to see all the boards. The indoor unit, you can access the elements, the expansion tank. Everything is easy to access, and it's really limited on your amount of connections. It's water connections between the indoor unit and outdoor unit. Next slide. Okay, I think, John, you were going to take over on the performance, I believe.
Sure thing. I'll take over from this point. Thank you very much for that, Jason. Okay. Do we have the slide for the performance? Yes, we were there. Okay. Okay. So some of the efficiencies of this product, the COPs, 4.9. 4.9 on the small sizes, 4.2 on the large size. We're using an integrated part load value as an average. We take the 25, 50, and 75 and 100% operation, and we use that as an integrated part load value. And those values are basically, because it's an average, you just get a single number for that. So we're at 4.8 to 4.9, 4.2. It's very similar to the COPs. Okay, next. So when we're taking a look at the performance of the heat pump, this is an example of the 28 size here, and the variables we're going to use as for discussion are 45-degree Fahrenheit air temperature with a 95-degree Fahrenheit fluid temperature for the building. So this is, we'll call it best scenario situation. So you can see that with that blue line, with those two variables, we have an energy output of the 28,000 BTUs for this unit. As the air temperature starts to get a little bit cooler, you start to see that energy output drop off. So this is where, of course, when you install any product, whether it be a heat pump or a boiler or a furnace, you're always doing some type of a a heat loss load calculation to ensure that the product you're installing has the ability to maintain the energy input for the loss of heat from the building. Hydronically, 95-degree Fahrenheit water is very low. And this would represent a type of a hydronic system such as floor warming, something with large mass. The rule of thumb is higher the mass, lower the temperature. So floor heating, floor warming has a very large mass. And because of the large mass, we can satisfactorily heat a building with a very low temperature. When you get into low mass, now we got to drive higher temperatures to get the same equivalent output. But in this particular sense, now we're losing the output on the heat pump here with that bottom green line. So that represents the 140 degree, which is the maximum temperature output of the heat pump. And you can see that at that point there, we're probably roughly half of the output because of the higher temperatures. Okay, next slide. So with this slide here, we're going to show when do we need backup heat, and there's two ways we can do backup heat for the heat pump. We can do backup heat either with the built-in electric coils that's in the indoor unit, as we talked about previously, and it adds either a 20,000 or 30,000, depending on the size of the heat pump you have, supplement heat to the unit, and we can use the backup coils as a true bivalent type output. In other words, the heat pump and the electric coils will work in tandem together. It also has the ability, the indoor unit has an ability to accept a dry contact from a backup boiler, for example. So say, for example, you have a backup boiler and you want the backup boiler to kick in at a certain outdoor temperature. You can program that into the indoor unit to hit that dry contact to the backup heating boiler, and that's would then effectively shut the heat pump off, and then you'd be a backup boiler only. So there's no bivalent operation between the heat pump and the backup boiler, but there is bivalent combination between the indoor coils and the heat pump. So what this graph is representing is the balance point. So we've interjected here a heat load in the system, which is about 26,000 BTUs. And you can see as we move on the right-hand side of that graph, the heat pump is going to satisfy the temperature for that particular building right up to about that 23-degree Fahrenheit point. And after that point, the heat pump is not going to start is going to start to struggle to heat. So now we need to find out when do we need to bring in our backup heat. And that's the point where we'd be looking at. So our backup heat would be using heat from 23 degrees down to -4 Fahrenheit. Of course, there's a point in time where the heat pump just cannot extract any more temperature out of the air, and that's going to be at -13 Fahrenheit. At that point, backup heat only is what you're going to use. So this, again, this chart is representative of a 95-degree Fahrenheit fluid temperature or a 45-degree or with a 45-degree outside air temperature. Okay, next slide. So if you're in a point where you want to use a heat pump more often and not use the backup heat, of course, you're going to have to get a bigger heat pump. And this bigger heat pump, this is the next size up from the 28 is the 43. And you can see from the chart right away, the balance point has shifted to a much lower temperature now for outside temperatures. And now you can use that heat pump with the same design load. Where we haven't changed our design output heat load. It's the same. We've just upsized the heat pump, and now we can use that heat pump, and our balance point has shifted over, making a much more narrow margin of when you're going to use your backup heat. Next slide. Very good. So that ends the performance portion of the presentation. Nick, do you want to come back around and we can look at questions?
Sure. Thanks, John. Thanks, Jason. Yeah, so again, we appreciate people taking times out of their day to join us for this presentation. And at this point, we hope we've given you enough information to be dangerous with. But if we haven't, feel free to ask some questions, and either myself, John, or Jason can answer those for you.
Yeah, there's one question, Nick. The question was, any reason why these use R32 when the rest of carriers lineup is using an R54B? Great question. Did you want to take that, Nick?
Sure. I could take that, and part of that is just some speed to market, as well as the product was being designed, it was designed with the R32 refrigerant, and that's kind of where we settled on that as we come to market.
One question I have is, it looks like you've got really good operating range down to, was it minus, sorry, the Fahrenheit and
13?
Celsius. Yeah,
Yeah.
minus 13. Uh, are there plans in the next generation to move to a colder climate? Just fair notice for everyone, I live in climate zone 6, so I'm always thinking about, minus 13, minus 14, minus 18. Are there plans to move to a monoblock that can handle a little bit lower exterior temperatures in the future?
Yeah, I'll take that one. I mean, I think you see the evolution of heat pumps with HVAC in general kind of
Yeah.
moving in that direction. So I can't give a guaranteed yes or no
Mhm.
answer on that, obviously, but I do think as the technology evolves and advances, that you're going to see it be able to do things otherwise believed to be unachievable with this technology.
Yeah, and not to take people behind the velvet ropes on product innovation, but I think that's been the amazing thing to me in this industry is what all of you have done around really optimizing these systems to climate zones, to colder and colder areas, and getting the same efficacy out of it. Uh, I really like what you're doing with the 3 kilowatt. It seems like just a couple of years ago, it was like you could add electric strip heat that would act as a backup, and it would just like bang 7 kilowatts on and then bang another 7 kilowatts on. And I really like this kind of modular approach of 3, 6, 9 kilowatts. Have you found that to be really helpful in, kind of staging the performance of that unit?
John, I'm gonna lean on you for that one. Either you or Jason, if you have that information available.
Yeah, no, we don't have a tremendous amount of feedback on the performance of electric coils. I think in certain colder conditions, some customers have opted to install the backup heating boiler, and
Hmm.
in some cases just say that at I'll use a Celsius temperature just because it's faster for me to think that way.
Yeah.
Just say 0 Celsius. I'm not, or 32 Fahrenheit. I know that one right away.
Yeah, I
Uh,
got that one too.
yeah. So we'll say 32 Fahrenheit outside. They're going to say, look, I just don't want to have a longer recovery time. I'm just going to flip this thing over to the backup boiler and let it do its thing. Uh,
Right.
that's some of the, but I haven't heard a lot of comments, feedback from that. Maybe some of the other product guys might have.
I mean, my intuition is it's one of the feedback things I've heard from a lot of our high performance builders. I
Mhm.
think it's very well played, and is going to be beneficial to you. Um, the storage tanks. So one of the things I mean, I like you've got 3 different sizes of storage tanks there,
Mhm.
and it seemed to me that that is a great thermal buffer solution depending on the system you're designing. So the largest system you could do was it an 80 gallon or a 70 gallon, John?
I think it's 79 gallon.
79.
79 gallon, but then you also have the other, what, 23 gallons in the buffer tank?
Yeah, I think it's important to differentiate that
Yeah,
the buffer tank and domestic hot water are not communicating into the same system. So the
yeah.
buffer tank is just looking after either the heating or cooling as its buffer tank load, and the domestic
Mhm.
hot water would divert its flow in a separate hydronic direction than the buffer tank. But what I would comment in on domestic hot water and if you have, depending on the home, it is, if you have, the big showers, the big
Yeah.
tubs, you have a big draw, yeah, put the larger size tank in place to allow you to have the best performance from that.
Yeah, I mean, I think that's great advice, John. I know some of the builders we've seen using heat pump water heaters. It pretty quickly became, let's just put the largest one into the system. But of course, back to Nicholas's point, I think we were seeing, and between the lines, what Nicholas was saying was, I was air conditioning my basement with a heat pump water heater, right? Even in the wintertime. Now you've got the ability to isolate that outside, but oftentimes that having that thermal battery storage, that larger tank on site gives you more flexibility in the system. John, I'm wondering if you've played with on the domestic hot water side, higher water temp, and then bringing that water back out with the thermostatic mixing valve back down to 120 F. So I have a bigger thermal battery storage, a bigger buffer, but I'm still tempering the water on the outlet side down to 120. Is that something you've studied yet, and if so, what are your thoughts? If not,
Oh yeah, absolutely. I mean, I think having that higher water temperature and using a thermostatic valve to tie down to bring it down to the more usable 120, 115 degree, probably the lowest temperature you want to go, makes sense to me.
yeah,
It just basically maximizes that storage. For example, I have a Beastman boiler in my home,
yeah,
and it has about
sure,
has about a has about a 26-gallon tank in there, and I keep it 140 degrees, and,
yeah,
I just mix it down because it's a smaller volume tank.
that's
But
right.
yeah, I maximize that through that process. But I think that's makes total sense to me as well.
Yeah. One of the things that I think is really incredible with these monoblock systems, I remember listening to a study from, I think it was the Department of Energy, that something like 60% of heat pumps in the United States were installed with the wrong amount of refrigerant in the system, which then impacted their performance. And I think what you're telling us with the monoblock is like, this is a factory set dose, and it's less likely to be installed or completely unlikely to be installed incorrectly. Can you kind of comment on that, John?
Yeah, I think that it really takes away the weighing of the refrigerant to make sure I got the right weight and charge to the right pressure. Having it coming out of the box all ready to go is, I think, a real time saver as well, especially for installers who, when you're quoting a building, you want to make sure your guys are in there. You have X amount of time. You're not going to be spending a lot of time trying to figure out how to make sure this is at the right pressures for that particular application. So
Hmm.
it makes total sense to me that the monoblock design was designed as a time saver for the installer.
Yeah, that's great. And how do you see it playing out with our subcontractor base, our installers? Because obviously we've got Nicholas lives up in New England. I used to live there. It's very much a hydronic market. I'm in
Hmm.
Minneapolis. We're a fairly strong hydronic market. John, you're up in Toronto, and you're a fairly strong hydronic market.
Hmm.
But in other parts of the country, I see that you need some level of coordination between your HVAC and your plumber now to execute a hydronic solution. How do you see that playing out as this product comes to market?
Yeah, I think really it becomes an education
Mhm.
in my mind. And hydronics, I can use the example of Europe. You mentioned how
Yeah.
you looked at this product in Europe as well. In Europe, hydronics is ubiquitous. It is like everywhere.
Yes.
This is just sort of the standard of how they heat homes,
That's
and
right.
to the advantage of the Europeans, they've been plagued with high fuel costs for
Yes.
decades. So they have driven the technology towards high mass, low temperature, fuel saving type applications. So when they made this pivot from the fossil fuel into the heat pump market, it was a really great match for them because they already had they could already maximize the efficiency of a heat pump with the lower temperature hydronic systems in place. So in North America, I think it's an education process, and I think
Yeah.
I could use as a personal story. I converted my house from a forced air. Not that I didn't like it, but I worked for a boiler company, so I better put one in. And we found that the comfort level of the home just went up tenfold. My wife just loved
That's
it.
it.
And then I
Right.
had neighbors. I had neighbors saying, "Yeah, listen, if I would have known about this before I finished my basement, I would have put one too." So it becomes
Yeah,
a word of mouth and education. And I think if the
sure.
consumer is allowed to understand what the benefits are with hydronics, they may come. Yes, it's more expensive, but
Yeah,
you live in a house and you want comfort. It's not a nice environment to have to always either put on a sweater or take off a sweater because you're too hot, you're too cold. The hydronics gives you a very steady, consistent, and quiet operation type of heating medium. So I think
yeah.
I think it becomes an education, and I think North America is far behind Europe. Of course, our fuel prices have been also we've had the luxury of relatively low fuel prices. So
Sure. No, I like what you're saying there about the comfort and the health part of it. It can be
mhm.
a better feeling type of heat in the home, but I still think I don't want people to. Maybe I'm misconstruing it, but uh, John, I think on your slide of showing the old style system where I've got a 1200 Fahrenheit blue flame that's delivering 72 degrees to my house. Uh, Within this system, I can still use a forced air system, but I'm going to have an A coil that is running hot water or chilled water through it. Is that correct?
Absolutely, yeah. You're going to use a hydronic coil, and I
Yeah,
think the rule of thumb should be oversize that hydronic coil.
that's
So
amen.
so larger the mass, lower the temperature,
That's right.
better the efficiency, better the output performance of the heat pump.
Yeah, and John, what I thinking we're talking about, and it's somewhat of a new talk for the United States, is this not energy conversation, but exergy conversation, right? That
Hmm.
we have you have a much smaller delta T with a air to water, back to air type system than you do with, again, burning a 1200 Fahrenheit blue flame in the house. Um, and especially if you start looking at radiant panels or chilled beams or radiant flooring, you now shrink that delta T within the system down to, I think you were talking about 95-degree output to deliver
Hmm.
72 in the house in a very quiet, comfortable way. So that seems to be the future. I just wanted people to appreciate that they can, still put a hydronic coil into an air side furnace system and execute with the existing ductwork. So great product for retrofit or new home construction. And
Absolutely, and
then,
I think I'll go. You
no,
finish,
go
please.
ahead. Go ahead.
I was going to say it gives the customer choices.
Yeah,
You're not limited into just polarizing into just an air exchange.
that's right. Yeah,
You could say, I want floor warming in my bathroom, right?
right.
Who doesn't like getting out of the shower into a warm floor?
Yeah,
Or you can put towel warmers. So you could
yeah.
put panel rads. Your options for comfort become much greater with the hydronic products. So I think this is where the real advantage of hydronics come. And again, as that education to the customer, if they know about it, they're going to ask questions. They're going to start saying, "Oh yeah, maybe I'm interested in that as well."
That's right. What are rollout plans for North America as you look forward? Is this something that we're going to see um, in distribution very shortly? Is it already there? What can we expect?
Yeah,
We'll
this
let Nick.
product is. Yeah, I was going to say this product
Mhm.
is one of our latest products to be released. So we are in the pre-sale stage of this. So starting to do things like these events to get the word out there on the product, and
Yeah,
then as people who have either attended or listened to this later, if they've got more questions or are interested in it, feel free to reach back at us, and we can make that contact on the sales side, and
hmm,
have further discussions. But yeah, it's available, effectively available now.
that's fantastic. And I'll tell you, one of the really exciting things for me was getting a chance to see this product on display at the EBA Summit, which was in St. Paul, Minnesota, a couple weeks ago. And I think a tremendous amount of excitement in the high performance homes industry about what this can bring to the marketplace. So, as always, hats off to you and your teams for bringing this. And the best person to reach out to, is that you, Nick?
Sure, you could start with me,
Okay.
and I could disseminate that through the organization.
Okay.
to make sure it gets to the right person.
That's great. So people can, if you can't find Nick's email, you can reach out to me, aaron@eba.org, and I'm happy to make the connection back to Nick. Well, great. Any other thoughts as we wrap up here today? Any other questions from our audience? I know we had a great one come in on the R32 versus 454B. Well, fantastic. John, Nicholas, Mr. Harris, Christina, thank you so very much for joining us today. And again, this presentation will be up at eba.org in our learning management system and on our podcast, Better Homes, Better Future. Thanks so much, everyone.
Thank you so much for having us. We appreciate
All right.
it.
Take care.
Thank you.
Bye.